Today, Trig students, we're going to solve some trigonometric equations. So we're going to be applying today some of our trig identities, so some strategies to solve these trig equations. We're going to be using our trig identities. So that there is only one trig function in the equation. So that's one strategy that will allow us to solve these. Another strategy will be to use some algebraic transformations, such as adding the same number or expression. And if we add the same number or expression to one side, we have to do it to the other side, which implies we have to do that to both sides. And some other algebraic methods, such as the most common that we will use is factoring. Okay. Since we are no longer proving, we may now work across the equal sign as we work to solve these. So as we work across the equal sign, since we are no longer proving identities. Alright, now the difference between general and primary solutions. Primary is what the actual answer that you get is going to be. So we'll either have one or two primary solutions depending on what trig function you are dealing with. A general solution just states that you're going to get the answer that you get plus all of the other possible solutions are the angles that are coterminal with those angles. So what you would do is write a formula for all those, and for right now we are not going to work with these because we're going to work on these primary solutions first. So initially we won't work with these. What we will focus on are the primary solutions, and those are the solutions of the trig equations in a specific interval. Primarily what we will use here is between 0 and 360, or if we were in radians, that x value would be between 0 and 2 pi. If we are in degrees, we are going to have our unknown be theta, and that will be between 0 and 360, as we said. Okay. A quick example here, if I have sine of x is equal to 0, well, in the interval between 0 and 2 pi, so on the unit circle, I would look where my y value is 0, right? Because that's what sine is. So where is my y value 0? Well, it is at 0 and pi. Okay. Now, you notice I used radians here, and that there's a reason for that. In order to determine whether your answer needs to be in degrees or radians, it's going to be based on what your symbol is, what your variable is. So degrees, our variable is going to be Greek letter theta, and radians, we will have a variable of x. Okay, so depending on what is contained within the specific problem, then you'll know whether to give your answer in degrees or radians. Moving into our examples here. So remember now, we can work across the equal sign. We're going to use the same general methods that we did to prove identities and things of that nature. So go ahead and get started here. Cosine of 2 theta is equal to negative cosine of theta. Since I have theta, I know I'm going to be looking for degrees, right? So just recopy the problem here. Initially, I see that I'm not even taking the cosine of the same value here, so I'm going to have to change that. And I know that this is a cosine double angle formula. So in order to write this as cosine of theta instead of cosine 2 theta, I can use one of those double angle formulas, and I would go to 2 cosine squared theta minus 1, and that's equal to negative cosine theta. So all I did was rewrite the left-hand side of this equation. And now what I notice is if I move this cosine theta over, I will have a trinomial, which I would look to factor. So that's what I'm going to do. I'm going to add cosine theta to both sides. So I would have 2 cosine squared theta plus cosine theta minus 1, and that equals 0. All I did was move my cosine theta over by adding to both sides. And now I look at this as a trinomial. Now if this is confusing to you, you can think of your cosine theta being like just any variable, just an x. So this would be like having 2x squared plus x minus 1. Okay, so if that helps, you might be able to factor that a little bit easier. I know that this will factor into 2 binomials. Okay, I know that in 1 I'm going to have plus 1, and 1 I'm going to have minus 1, right? Because that's the only way I can get that negative 1 on the end. And I need to end up with a positive in the middle. So I'm going to want whatever gets multiplied by the positive to be my larger number. So that's going to be my 2 cosine theta. And this would just be cosine theta. Okay. So I can go backwards, make sure that when I would FOIL, if you remember that, first, outside, inside, last, make sure that that would equal this up here. And as I said, if you want to think about this as being 2x squared plus x minus 1 and factor that, you can. And then just realize that wherever you have an x, it should be cosine theta. Okay. Alright, now if this whole thing equals 0, that means that one of the contents of these parentheses has to equal 0. Because the only way for me to get 0 is if either this whole thing equals 0 or this whole thing equals 0. So we have to remember back to some of our algebra here. So I'm going to set up 2 equations. Cosine theta plus 1 must equal 0, or 2 cosine theta minus 1 must equal 0. I'll solve this one on the left first. Cosine theta would have to equal negative 1. So I could go look on my unit circle, realize that between 0 and 360 there is one location where cosine equals negative 1, or where my x value is negative 1, and that is that theta is equal to 180 degrees. Now if you didn't have your unit circle on you, you could have done inverse cosine of negative 1, right? Okay. Now down here, I would move my 1 first, so I'd have 2 cosine equals 1. I'd have to divide by 2, so I'd have cosine theta equals 1/2. I'd look on my unit circle, figure out where I have a theta or a cosine of 1/2, or where my x values equal 1/2, and I would find out that theta could be 60 degrees, or theta could be 300 degrees. In both spots, my x value is 1/2. Okay, so if I'm looking at this, if I were, trying to visualize this on the unit circle, that 60 degrees is up here, right? Remember, we're working from, I know we did some vectors for a while, but now we're going up. There's 60 degrees. It's cosine of 1/2. And then 300 degrees all the way around there, right? So that was those two. So I've actually got 3 primary solutions for this. Okay? And that would be all you need to do there. Let's go over to this next one. Let's see here. Whoops. So tangent of theta equals 2 sine of theta. Again, I want to find theta when it's between 0 and 360. So again, I'm dealing in degrees here, right? So let me move this up just a shade. Tangent I can do in terms of sine and cosine, right? So that would get me closer. So let's go ahead and change tangent to sine theta over cosine theta. That's equal to 2 sine theta. Okay. Now, I want to look. I really want to get rid of this denominator. So I could, in order to get it out of there, I could multiply both sides by cosine, right? So if I had sine, if I did that, multiply both sides by cosine, I'd end up with sine theta equal to 2 sine theta cosine theta. Okay. Now, a lot of times I'll be looking to get something equal to 0, right? So move things away. So what I would want to do, I recognize I have a sign here in both. So if I move this over, I'll be able to factor out that sign, and that might get me somewhere. So let's go ahead here, and I'm going to subtract this whole side over to the left. So I'm going to end up on the left-hand side of this equation with sine of theta minus 2 sine theta cosine theta. And that's going to now be equal to 0. Now these share something, so that means I can factor those out. If I factor out a sine theta, divide a sine theta out of there, I would just have 1, right? Minus, if I take out a sine theta, I'm left with 2 cosine theta. So now I've got things being multiplied by one another, so I know that either sine theta has to equal 0, or what's in this parentheses here has to equal 0. So I'll set up my 2 separate equations. Or 1 minus 2 cosine theta must equal 0. Solve the one on the left first. If sine of theta equals 0, then I know that I look at my y values, and theta, theta could equal 0 or 180 degrees. Okay. If I didn't have my unit circle handy, again, you could do inverse sine. The only problem with that is, remember, that's only going to give you one of these answers. You need to know that the other one would apply as well. Now, the other one. What I am going to do is I got to move the 1 first. So I'd subtract 1. So negative 2 cosine theta equals negative 1. Divide by a negative 2. So I would have cosine theta equal to 1/2. Again, I could look at my unit circle or go cosine negative 1 or inverse cosine 1/2. And if you use your calculator, it will give you 60 degrees, but you need to be aware that, remember, there is another position between 0 and 360 where the cosine of theta is equal to 60, and that would be at 300. Okay. So for this one, I have 4 primary solutions. Okay, so your answer would be 0, 180, 60, or 300. Alright, last couple here. Solve 3 sine x secant x equals secant x between 0 and 2 pi. So I have x here, so I know I'm going to be dealing in radians. So let's recopy the problem. 3 sine, 3 sine x secant x equals secant x. So again, I notice I have the same value in each, or on each side. So if I subtract this over, I'll be able to factor that out, and I'll have a multiplication problem equal to 0, which is what I look for in order to factor. So let's do that. Let's change that. 3 sine x secant x, and I would move that by subtraction. So minus secant x, and now that would equal 0. They have in common secant x, so secant x. So I'd be left with 3 sine x minus 1 equals 0. Since I have a multiplication problem equal to 0, I know that either this equals 0 or this equals 0. So I would set this up secant x equals 0 or 3 sine x minus 1 equals 0. Alright. Do the inverse secant in order to find out what x equals, and you realize that that does not give you an answer. So that would be no solution there, so there's no way that would equal 0. Go over here and solve this one. 3 sine of x would equal 1, because I'd add 1 to both sides. Sine x would equal 1/3, because I would divide both sides by 3. So inverse sine 1/3, and that gives you x is equal to 0.34 radians. Now, what you need to understand here is that is not your only answer. Remember, if sine is positive, it is going to be in the first quadrant, so 0.34, or the second quadrant, because remember the sine is our y values. So all of our y values are positive in the first and second quadrant. So you have to go over here, and so I'm finding this value, which is 0.34, but then I need to find that value to that reference angle over there. Therefore, in order to find the other value of x, I would have x is equal to, if I were to go all the way over, that's 2 pi, right? Well, I didn't quite make it all the way over. I was 0.34 shy. So, x could also equal 2.80. Okay, because this would be 2 pi minus 0.34. I'm sorry. Did I put 2 pi there? That's my fault. So erase that if you had 2 pi in there. Remember that 180 degrees is equal to just pi. Got a little ahead of myself there, thinking about another problem. So anyway, pi minus 0.34 would be 3.14 minus 0.34, which is 2.80. So my answers for this be x equals 0.34 or x equals 2.80. Getting here, not so bad. You just need to remember there is possibly another answer for a primary solution to this problem. Okay. Now, we have one other type of problem that we will need to understand here, and that's when our variable or our unknown theta is intertwined with another value in here. Okay, so what I need to do first off is think of this whole part in here as being my unknown. Well, how I would get, I want to figure out what does this whole thing need to be. I'm not worried about theta yet. So in order to figure out what could possibly be in these parentheses as a whole, I have to do the inverse sine of 1/2. Okay. And as we know, that gives us 30 degrees. And we also know that it would be 150 degrees. Now you can get that by taking 180 minus 30. Or you remember, you can look at your unit circle, and these are values that are on our unit circle when sine equals 1/2. Alright? So the things you're going to want to have handy when you're working on all this is, first off, your unit circle, and secondly, that formula sheet that I gave you for the last exam. That'll come in handy as well when you're trying to solve these and rewrite some of these equations. Okay, so if I know the sine of 1/2 has to equal 30 or 150, I know that that needs to be this entire value. So that's not what theta has to equal. Okay, I know that theta plus 40 either equals 30 or theta plus 40 equals 150. Okay, which means that theta would either equal negative 10 degrees or theta would equal 110 degrees. Now, one problem. It asks for my answer between 0 and 360. This one's okay. This one, however, is not. I need to think, where is negative 10? Negative 10 is right there, right? So I need to figure out what is it to there. Well, that's a simple calculation of 360 minus that reference angle of 10 degrees, so theta would actually equal 350 degrees if I'm thinking about my primary solutions as being between 0 and 360. Okay. Now when you come back into class, actually we're going to watch this in class now. Your written exercises are going to be 1 through 12 all, and you'll begin working on those now. Have a good day.